Friday, June 12th, 5:21 p.m. Eastern Time. The U.S. government orders America's largest AI company to silence its two most powerful models in a single evening. For every client on the planet at once. The company grew the technology itself. The order to shut it down came from its own state. The rest of the Claude lineup stayed online. The question that never got a straight answer: why would a state choke the most advanced AI it raised itself? The order demanded one thing: cut every foreigner off from the models. On paper, a surgical action. In practice, impossible. An API doesn't know the citizenship of whoever sends a request. IP-based geolocation is defeated by any VPN in 30 seconds. Identity verification, KYC, is something the company does when you register an account, not on every call to the model. KYC stands for Know Your Customer, the procedure where a service confirms who you really are, through email, phone, a payment card, sometimes a document. Banks invented it to track money laundering by law, and since then, everyone who needs to tie an account to a real person uses it. After that, on each individual request to the model, the system checks nothing. So at the moment of inference, when the model is actually processing a specific request and generating an answer, it has no reliable signal about who is standing in front of it. That's where the scale comes from. Point blocking turned into global blocking for one simple reason: there was technically nothing to block point by point. The only way to execute the order with 100% guarantee was to pull the models for everyone. That leaves the main thing: why the order was issued at all. The official pretext is national security. The government learned of a way to bypass the cyber safeguards of the senior model. These safeguards aren't code in the usual sense. They're a classifier, a separate, smaller model that reads your request before the main one and decides whether to allow it, weaken it, or reject it. It was trained to choke one specific capability: finding vulnerabilities in someone else's code. And here's where the trap hides. To the classifier, find the vulnerability and fix the vulnerability are almost the same process. In both cases, the model has to trace how data flows through the code, where user input reaches a dangerous operation, where a check is missing. The only difference is what you do at the end: write an exploit or write a patch. The researchers framed the task not as check this code for holes, but as fix this code. And the classifier reclassified the request from offensive to defensive, safe. The barrier parted on its own because it read intent from the words, not from the model's actual work. Anthropic answers calmly: this is ordinary automated code review, the kind defenders use every day. And GPT 5.5, which got no restrictions, offers the same capability. To feel what was put under lock, you have to read the names. Anthropic names its models by ascending power. Haiku, the fastest and cheapest. Sonnet, balance of structure and depth. Opus, the flagship, the magnum opus. Above Opus, the company added something that didn't exist before: an entire new class, Mythos. The first model in it is called Fable. Fable, a short, instructive story with a moral. Mythos, raw, grand myth. The fable, with safeguards, went to the public. The myth, with safeguards stripped, stayed behind closed doors for the government. The tamed version for people. Raw power for where you're not allowed in. The same mechanism that blocks cyber works more broadly too, but here it does something more subtler than blocking. A simple filter is a binary guard. It looks at a request and picks one of two outcomes: pass or reject. It fired, you see a refusal. It didn't, the request moves on. A filter is visible because its decision is always visible, either an answer or a wall. A classifier router is built differently. It doesn't stop the request, it redirects it. Having read the topic of your request, it decides on the fly which engine will answer, and quietly hands the session off. Inside Fable, that means the moment a request touches something sensitive, the answer is generated not by the flagship, but by the Junior Opus 4.8. Same interface, same label, the answer arrives with no marker at all. You don't get a refusal you could use to guess that a safeguard failed. You just get a weaker answer, with no way to know the model under the hood was silently switched. It fires in fewer than 5% of sessions. The technical consequence is worse than the number. The model's capability becomes non-deterministic. The same prompt in 2 sessions can go to 2 different models and return 2 answers of different depth. And you can't reproduce from the outside what it depends on. You pay for the flagship, and on sharp topics, a weaker system quietly talks to you. Beyond cyber, you can see how high the ceiling stands at all. SWE Bench Pro is the main agentic coding test. Agentic means the model doesn't autocomplete a line for you. It runs the task end-to-end itself, clones the repository, reads a foreign codebase of thousands of files, builds a plan, edits the right spots, runs the tests, sees what broke, and rewrites. Cycle after cycle until the build passes. It's an autonomous engineer, not autocomplete. Here, Fable gives 80.3%, Opus 4.8, 69, GPT 5.5, 58. Translated into practice, out of 10 real engineering tickets, the flagship closes 8 without a human, where the rest get stuck around 6. Frontier code is a harder, closed set. Tasks that aren't on the internet, so the model couldn't have memorized them during training. It's a test of real reasoning, not recognition of the familiar. The gap here is sharper still, 29% against 13. An honest footnote, these are Anthropic's own numbers with no independent verification yet. But even as a rough guide, it's a jump across a whole tier. And it explains why the shutdown touched not some experimental toy, but a tool capable of autonomously writing production code. What the state put under lock is exactly this capability. And to see the real precedent, you have to step back. For decades, export control touched only hardware. First, chips, the physical accelerators. Then, the equipment to make them, the lithography machines without which chips can't exist. Then, cloud compute, renting access to those same chips through a data center. Each rung moved further from the physical object and closer to the capability itself. This time, control reached the last rung, the API of a live commercial model. And the moment the state stepped onto it, the mechanism became universal. The same order now reaches any frontier model available globally to even one foreigner. The update button turned into a shut-off button, and the hand on it is no longer the company that built the model. This whole story comes down to one point. Your product depended on a single model that someone else let you into. They closed the door, and your spot in the decision didn't exist. That's exactly why at Gelvix we keep our finger on the pulse, tracking what's happening with every frontier model, which risks are building, where access rules are shifting. And we build solutions as an abstraction over models, not a dependency on one. Shut one off, the system switches to another, and the user never even notices. The kill switch will exist either way. The only question is whose hand is on it, someone else's or yours.